Commercially friendly. I've already done this one too. Okay. So if you thought e to the x was easy, this one is just as easy. E to the x, the derivative is e to the x times its derivative of the exponent. This one, the derivative of ln of x, well first actually, let me back this up. Ln, remember, is the natural log, so it's log base e. We are going to do derivatives of log base 10s or log base 5s or log base, we'll do that after the quiz. But this is a log base e. That's what an ln stands for. We just don't write it as log base e. We just write it as ln. So the derivative of ln of x is actually 1 over x. That's it. Derivative of e to the x is e to the x. Derivative of ln of x is 1 over x. So what if this was not an x? What if it was a u? What if it was like an x squared or a 5x or a 2x? What do you think? What would you think would change? So it'd be 1 over u times the chain times the derivative. That's it. That's the new thing you got to do. You're supposed to make these all one fraction. I'm going to let you know that at the end we can leave it as 2 separate fractions, but you are supposed to make everything as one entire fraction. So let's take the derivative of this first one, the ln of 5x squared. So this is my u. So I would write 1 over 5x squared times the derivative of that. What's the derivative of 5x squared? And again, I would like you to clean this one up. This one's not too bad. You can cross cancel. 5 goes into 10 twice. X and x squared can go into each other with an x on the bottom. So your final answer is 2 over x. Easy. This is a squared, by the way. Sorry, it looks weird. All right, so what would I write for this derivative? 1 over squared plus 4 times 4x, that's it. Write it as one fraction, 4x over 2x squared plus 4. Can that reduce further? Yeah, you want to kind of reduce it further, so divide everything by 2. So you should have 2x x squared plus 2. Easy. What did I do here?
Coefficient,
Product rule, not a coefficient. If it was a coefficient, you just attach it along. If it was just 5 ln x, it'd be 5 over x. But this is a product rule. So we'll go through it. We do first, this is chain, times, what's the derivative of ln x? 1 over x. Plus the second times the derivative of the first, which is just 1. I do want you to clean this part up here because that will reduce. What is an x times a 1 over x reduce to? 1, not 0. Just because these cancel, it still reduces to 1. So it's 1 plus ln x. 1 plus ln x. All right, last one is ln x is on top, so it's a quotient because you've got an x squared on the bottom. So we're going to do quotient rule. Y prime. So we'll go through the quotient rule together. Quotient rule says denominator times the derivative of ln x, e, 1 over x. Derivative. Denominator times derivative of the numerator minus the numerator times, what's the derivative of the denominator? Okay, I want you to be careful right here. If you just wrote times 2x, you would think that you would be allowed to multiply this x with the 2x. You are not allowed. Ln of x is its own quantity. It's like cosine of something. It is not allowed to separate from the ln. So you almost have to put that 2x by itself. You cannot multiply those together. It's ln of x, and then 2x is being multiplied to it. It's not the ln of 2x squared. Okay? So just so you know, and actually what I normally do is I put that monomial, I actually put it in the front of ln x, which I will in a moment. All over the denominator squared, which is x to the 4th. All right, let's clean this up a little bit. X squared times 1 over x is just x, agreed? Minus, I'm going to put that 2x in front so I don't get confused. And then you are allowed to reduce these x's, not with this guy. This ln x is like again, it's like cosine pi. You can't touch anything after the word cosine or sine. You can't touch anything after word ln x. So I can reduce all these x's. So my final answer would be 1, right, x cubed. 1 minus 2 ln x all over x to the third. I just reduced an x. Don't touch that x, though. So far, so good? 1 over, and then multiply by the chain. 1 over, multiply by the chain. Now, last two. The last two, very easy, but something that you have to keep in the back of your wheelhouse here, of your brain. Sometimes you need to rewrite before you differentiate. And I'm putting that in bold letters because I know for sure it's on SPCC. I know for sure it's on homework tonight. And you're going to come to one problem and you're going to be like, huh? This is so hard, when really you should have rewritten it. And I'll show you what I mean in a minute. Let me write these two problems out. X squared plus 1 squared. There we go. So this first one here, you could call this a u, yes, to a what power? 1/2. Then you'd have to do what? Chain 1/2 u to the negative 1/2 times the chain and do all that. Something way easier to do. Go back to remembering you are allowed in logs to what's called expand them. Expanding a log is so much easier to take derivative of. It's the same as trig. It's much easier to take the derivative of, cosine 2x than it is to take the derivative of sine squared x minus cosine squared x. It's much easier. So if I rewrite this, I would actually rewrite this. I'm not taking derivative yet. I'm just going to rewrite this as the ln of x plus 1 to the 1/2. Do you all agree to that? Right? Do you remember with logs, where does that power go? Where could I move it? In front. Oh. Why is that helpful? Well, because now it's a coefficient. And coefficients just get attached to derivatives. Here's what I mean. If I take the derivative now, the derivative of 1/2 ln of x plus 1, that coefficient just gets attached. I mean, you could do product rule, but you'll see the 1/2 just gets attached. Times, how do you write the derivative of ln of anything? 1 over x plus 1 times this derivative. What's the derivative of x plus 1? I mean, you can put a 1 if you want to. The final answer is 1 over 2x plus 2. Rather than writing this as a u, would I have to do that? Rather than doing that, that's what the answer would be. That's what it would simplify out to be. So you could actually do, like I said, you can rewrite it, expand it, and then take the derivative of each one separately. Let's do it again. Let me show you on this one. This one even looks harder. Look at this one right here. This is, oh my gosh, this is a product rule. Do you see that? With a u. With the chain. No. Way easier to do. Wait until I do this one. This is, if you get a problem like this, you're like, oh my gosh, I have to do a u with the product. Think to yourself, I'm working too hard. Expand it out. When you are multiplying inside of a log, do you remember how to rewrite that? What do you do when you multiply inside of a log? How do you separate it? How do you expand it? Exactly. Expand. You would write this as the ln of x plus the ln of x squared plus 1 squared. Now, where does that 2 go? In the front. So let's put it there. And now that you've rewritten it, now take the derivative of each one separately as its own polynomial-ish kind of thing. What's the derivative of ln of x? Easy. 1 over x. What's the derivative of 2? Well, that's just a coefficient, so I don't have to do a product rule. So I just write 2 times, what's the derivative of ln of x squared plus 1? It'd be what? 1 over x squared plus 1 times what? 2x. So really, what would this be rewritten like? 4x over x squared plus 1 plus 1 over x. I will let you leave it like this as 2 separate fractions. I will tell you, though, you should know how to write it as 1 fraction. I'm going to show you how to write it as 1 fraction, but I'll let you leave it like that. But to write it as 1 fraction, you remember if they have 2 different denominators, you just write them both next to each other? And then do you remember like you crisscross? So you would have what? X squared plus 1 and 4x times x is 4x squared. So, oh, this wasn't that bad. So what? 5x squared plus 1 over x times x squared plus 1. That really is the better answer, but I would let you leave it like that. That's it. So tonight's homework, the whole point of this section was 1 over times the derivative. Done. And I'll put back up homework.